Make sure you get your binders caught up. Give you a few minutes there to get those in there. We're gonna go on now. Also, by the end of class, before you take off, make sure your test over laws laying right here. If you have the vocab done, lay it right there next to it. If you don't have the vocab done during intervention, if you can get a computer, it might make it a little easier, because I know a couple people in first block, they just printed it off on their computer,
What?
the vocab. So they matched them up and then just printed it instead of have to write it out. So that would make doing that vocab a little easier, maybe if you have a printer. Today is the 28th. Go ahead and start copying this. This is your notes for today. We'll get finished probably quite a bit early today, so you have time to go back and work on those theorems and postulates and axioms and corollaries if you want.
8-1.
Teachers, excuse the interruption. I
Yeah.
need Caitlin Smith to the office, please.
Is this a different chapter though?
Yeah, it's chapter
So I
8.
can put chapter 8 at the top.
Yeah. Yeah, this is chapter 8. All right, what we're going to deal with, we're going to go back to dealing with polygons. We dealt with polygons earlier in the year. Going to do a little, and actually we've been dealing with polygons ever since then, because all the stuff that we've been doing with triangles, triangle is a polygon. So we're just going to deal a little more with polygons, and most of this chapter is going to deal with four-sided polygons or quadrilaterals. So properties of rectangles and rhombus and trapezoids and parallelograms, so on and so on. And I'll forget to say it probably throughout the chapter. All the stuff that we deal with in this chapter will be convex. Remember back at the start of the year, we talked about convex and concave. All the stuff that we'll deal with are convex. So if I don't say it's a convex polygon, know that it is a convex polygon, because that's all we're going to deal with. All the formulas and stuff that we're going to learn today only work for convex polygons. Notice there's like 4 different things here. And this is probably going to be the most confusing thing throughout this chapter, is you got to read the problems carefully so that you know if you're finding the sum of the interior angles or the sum of the exterior angles or the measure of each interior angle or the measure of each exterior angle. Because when I write, or when you see a problem and it says find the sum of, and then the next problem says find the each interior, so on and so on, it could get confusing very easily. We're going to have a formula for each one of these 4 things. There's going to be a formula to find the sum of the interior angles. You already know the sum of the interior angles for one polygon. Sum of the interior angles of a triangle is always what? What is it, Brian?
180.
180. The sum's always 180, right? How about a 4-sided, a quadrilateral? What do you think the sum there is? 360. Anybody know 5-sided, a pentagon?
420. 270. 480. 120.
And we're going to talk about that. You're going to see the pattern.
Isn't it like you do? This is the like. Isn't there equation or whatever?
And that's what I'm getting ready to show you right now. So there's a pattern to that, and there's a formula for it, and that's what we're gonna do. What kind of polygon is this one? Just real quick. Hexagon, how about this one?
Octagon.
Octagon, how about this one? Ah, be careful.
Square. Quadrilateral.
Quadrilateral. How come you can't just call it a
Because
rectangle?
there's not, you don't know there's four right angles.
Alright, to know it's a rectangle, it'd have to have 4 right angles, and they didn't tell you that. And that
Then
later.
why when you're in kindergarten do they say that?
Yeah, because they don't think that you can
Comprehend.
comprehend any
Or
farther
like,
than that.
this is a shape,
They-
learn it.
If your kindergarten teacher held that up and said, "What shape is this?" and you said a rectangle, and she said, "No, we can't tell it's a rectangle because it
Well,
doesn't
they taught us
have
that
4
it's a-
right angles."
No, it's
Quadrilateral
not.
at first, like,
is
instead of a rectangle.
Hayden's kids are gonna learn quadrilateral at like 2 years old.
No.
There's certain things in math that you, and I've told you throughout the year, you know, not that your teachers lied to you, but
They withheld
they-
information.
they didn't tell you they withheld information. They didn't tell you the whole truth about certain things, because you can't just pile all of math on you all at once. It's gotta be given to you in little parts. And they
When
didn't,
you're young, you're more, the ability to learn is better.
that's true.
You just learn all the maths.
Yeah.
Learn calculus by the time
Dude,
you're
Peyton's
10.
kids are gonna come
I-
home and be like, Dad, I went over
I don't know
rectangles."
that would really
He's
work,
looking at it,
because
why is it a
your
rectangle?
ability to learn is better, but the ability to comprehend,
Retain that information.
Isn't
is very
there.
low.
right? That's
Right.
why a 5-year-old might still go up and touch the top of a stove when it's hot, but we hope that somebody of your age doesn't do that.
Marissa still does that.
Mercy, you still do this?
Peyton Harris and Dave
You gotta remind yourself, is that hot? Oh, yeah.
That's how you learn, you let them do it. My dad let me hit myself on everything. So I was like,
Alright, so this first formula, sum of the interior angles. So that's all the interior angles. And it's always gonna be this formula, n minus 2 in parentheses times 180, where n stands for the number of sides. Now, n stands for number of sides, and you might think, well, we're finding angles, why are we dealing with sides? Well, the number of sides in a polygon and the number of interior angles and the number of exterior angles are always the same. So if it's a 5-sided figure, a pentagon, it's got 5 sides, it's got 5 interior angles, it's got 5 exterior angles. If it's a 52-sided figure, then it's got 52 sides, 52 interior angles, 52 exterior angles. The sum of the exterior angles, and we're going to do a couple with this formula here in just a minute. Sum of the exterior angles, I'll probably get a couple of you because I put problems on the test. I'll put a problem on the test that will say something like, you got this shape that's a 15,200 gon, and I want you to find the sum of the exterior angles. And sure as anything, I'll have people plugging into this formula up here, doing 15,200 minus 2, then trying to times it by 180 and getting some great big huge number. But if it says find the sum of the exterior angles, all the formula is it's always going to be 360 degrees. So the exterior angles of every polygon in the world, if it's convex, will always add up to 360. So if I have a triangle, and on that triangle, you got 3 interior angles, that's an exterior angle, that's an exterior angle, that's an exterior angle, those three exterior angles are always going to add up to be 360 degrees. If I have a hexagon, the sum of the interior angles is one thing, and you can plug into this formula and find that. But the 6 exterior angles, if we were to draw in one at each vertex, those 6 exterior angles are always going to add up to be 360 degrees. So sum of the interior angles, it's going to be different for each polygon. Sum of the exterior angles always going to be the same. And that's the sum on both of those. That doesn't tell us what each one is separately, just tells us that all of them have to add up to be a certain number. Like with a triangle, you know that all 3 interior angles always have to add up to be 180. Doesn't tell us what each angle is separately, just tells us that they all have to add up to be 180. All right. With regular polygons, what's a regular polygon again? We talked about them earlier this year.
They have all the same angles and all the same sides.
All right. All sides congruent, all angles congruent. So that's a regular polygon. I'll give you a second to write this down. On this formula right here, I've got it written, because I'm not very good with the computer, might be better to write it like this. N minus 2 times 180 all over N. Same formula, it just looks simpler the second way. I just couldn't figure out how to do it on the computer. Emma sitting at home messing with us. So Weston get hit during a trail ball game.
Got hit by Trey, I know that.
Was it hit by Trey?
Yeah.
He just sent me a Snapchat of just his face and just like this bulging red thing
So
on his
during,
eyes. Like,
was it during the game or what?
he sent me a picture of when it happened and I was like, oh, that's horrible. Why are you taking photos of yourself? Get some ice.
What did I do? That'd be the first thing I did.
Selfie.
Put this in a selfie contest. I did grab a cauliflower here.
All right, so with the regular polygon, if the polygon's regular, and that's a lot of what you see in the real world are regular polygons. A stop sign is a regular octagon. A caution sign along the road is a regular triangle, so on and so on. A lot of the things that you see are regular polygons. All sides have to be the same, all angles have to be the same. So if you were looking for each interior angle of a regular polygon, it only works for regular ones. If it's not a regular polygon, then it doesn't work. If you're looking for each interior angle, you do the n minus 2 times 180. That's going to tell you the sum of all the interior angles. And then you just divide by the number of sides, and that tells you each angle separately. So for a triangle, if it was a regular triangle, we didn't call it a regular triangle. We've been dealing with them for quite a while now. If you find the sum of the interior angles, well, we already know that's 180. Divide by the number of sides. What's 180 divided by 3? 60. What do we call these triangles? We didn't call them regular triangles. Equal angular or equilateral. Now you got to be careful because the triangle is the only one where if all sides are the same, all angles are the same too. Or also, with a pentagon, since it's baseball season, home plate
All angles
on a baseball field, all the sides are the same. All the sides, I think, on the home plate are like 10 inches, but all the angles aren't the same. All right? So home plate's not a regular pentagon. We do know that
These are 90.
those three right there are all 390, and here in a minute, we'll be able to figure out, because we'll know what all the angles in a pentagon should add up to be, and we'll be able to figure out what those other two angles are. Each exterior angle, so if you have an exterior angle here, and you know it's a regular triangle or any regular polygon, you can find each exterior angle just by taking 360, the total of the exterior angles, and dividing by the number of sides. So for this equiangular triangle here, what's this exterior angle always going to be? 120. And probably the easiest way to find that, if you know the interior angle, is this last thing down here. Each interior angle and each exterior angle always have to add up to be 180. So any interior angle and exterior angle that are at that same vertex, they always got to add up to be 180. So a lot of times when you're building something or you're doing whatever it is that maybe you're working on, instead of, if we have some shape, instead of dealing with this, if I could draw something straight here, instead of dealing with that interior angle, because maybe it's more than 90, more than we can actually get to, and this exterior angle is less than 90, a lot of times if I'm building something at the house and I want an angle, maybe I'm building a table of some kind or something, and I want an angle that's more than 90 degrees so it looks fancy or something. Well, what you can do is, instead of worrying about the angle that you're leaving there, you can measure out this angle and then just cut away the angle that you don't want out of 180 and get rid of that part. But that's why we deal with exterior angles sometimes, because they're easier to get that cut off. If you worked at like a metal shop or a machine shop, some of those, if you've ever seen those big cutters for metal that come down and they slice the metal, and we used to have one down here in the shop. I think it's still sitting down there because I'm sure they didn't move it. It weighs about 6,000 pounds or something. So it's called a brake, and they push down on it and it breaks the metal, cuts it off. Well, it only goes up to a certain angle. It only goes up to like a 90-degree angle that you can cut. Well, then what you do is cut off the angle that you don't want and leave the bigger angle. All right, give you a second to draw this chart. I just added this chart in today, so if you happen to get online and look at the notes, I'll have to re-download the notes. So I was sitting in here first block and thought, you know, I could make this a whole lot easier if I put a chart in this. Then we could just fill in the chart.
3, 4, 5, 6,
There should be
13.
13's right, isn't it? 13 going this way and 6 going across. Peyton, has your brother been playing a lot of baseball?
Yeah, he's playing on 2 teams this year. But one's rec and then he's playing on travel. He had a tournament this weekend,
Did he?
and they had opening day already.
My coach is, or my son is a main coach. Of course, my youngest son, he's got a big mouth. So Mr. Fisher has a team that my son plays for. He's not supposed to be playing for him because this other guy play for our team, you gotta quit all those other teams. Well, my youngest son had to open up his mouth. Come on, TJ, we gotta hurry up and go to your other game. His coach heard it. You can't be playing for other teams. Got all upset with him. They're smashing the teams yesterday, beating them like 8-1. Then all of a sudden our pitchers can't throw strikes. And we end up losing in like 9 innings.
He's pine.
And I'm like, what? This is, and the team was not good.
Pine Top. I know it. Okay, Top. I think it's hilarious how like a lot of rec leagues, it's like just a pitching duel the whole game, or just like the batters just go up, just like
I know.
smash them out. It's like who can ever smash the
My
most
sister-
really
my
far.
sister's softball team, it's their first year of kid pitch, and like, I remember when my brother played first kid pitch, like, it's all walk after walk.
So you
Then
said,
now they end up winning like 18-1 and stuff, that's because we have like one good pitcher, where if you get one good pitcher for at least a little bit, you can win, 'cause
Oh yeah.
the bad thing is, most of those.
it takes forever to.
Yeah, some rec teams, they don't, but you get into like my youngest son's in a traveling team for 9-year-olds. And you get that one pitcher, but they only let them throw like 30 pitches a game or something.
Yeah.
They're only allowed to throw 30 pitches or 35 or something like that.
You like throw out all the good pitchers' arms because you just don't want to lose. So just like you just go out there and tear your shoulder apart.
I don't know, the older son, I don't know what's happened to their pitching, they just fall apart.
We're just like, all right, we're just gonna send every good pitcher in and hopefully just beat them very fast and you don't have to pitch.
We had a kid that was like 13 years old and weighed, he's probably about 5'11" maybe, and he weighed about 210. He's about my size. It broke his leg. He was our number one pitcher, so that really hurts when you don't have him to throw out there.
For 11-year-olds?
No, 13.
We broke other kids in every game. We would always like
He's a big kid.
dislocate someone's bone. Like Taylor slid into first, dislocated his hip. We're like, all right,
That's a monster guy.
just let him just walk through the bases, I guess.
And rec, I'm untouchable. That's why I don't play high school, because I don't know what that.
All right, on this, we're gonna go run through this just real quick. What's a 3-sided polygon called?
Triangle.
Can fill all these in, you can fill them in. 4-sided,
Quadrilateral.
thought somebody'd say the wrong thing again. Quadrilateral. 5-sided, 6-sided,
Hexagon.
7-sided.
Septagon.
All right, you could use septagon. That's what some books are using now.
I can't remember what the other one was.
Or heptagon.
Well, that's what I'm saying.
Heptagon is like the old school one. Septagon is one that's acceptable now. 8-sided,
Octagon.
octagon,
Nonagon.
nonagon,
Decagon.
decagon. Notice I skipped 11. It's not because I don't know how to count. Usually we don't give an 11-sided figure a name.
I didn't even see that.
You could look it up and figure out what an 11-sided, you could give any shape a name like this, but these are the basic ones. 12-sided I put on here just because the book seems to use this one a lot, and it's called a dodecagon.
When do you get in, when does it start where you just have like the number dash on?
Right after this. So after 12, usually those are the only ones that we give names to. Anything else, we just call it,
A 100 is a septagon.
And we go.
right. And, but
Like 40
again,
seconds.
probably in the book, they probably won't call it a synagogue. They would probably just say it's a 100 gon. Because once you get past 12, it's just too much to remember. I mean, you could give every single one of them some kind of name, like a 13 might be a tridecagon or something like that. But we don't give them those names.
Right now, all
All right, the next one, sum of the interior angles. And we'll list all these out. Maybe it'll make it a little easier. If you're looking for the sum of the interior angles, well, you already know the interior angles of a triangle add up to be how much? 180. So you can write that one in.
Mr. Eversole.
Yep.
Hey, Suresh.
Yeah.
Oh, I can figure out all of these.
Now, to figure out the rest of them, if you use that formula, and we really don't have to use that formula every single time because there's going to be a pattern. And once we figure out the pattern, then you could just go by the pattern. Four-sided, so in place of n right here, we put in 4. What is 4 minus 2? 2 times 180?
360.
360. So sum of the 4 angles of any quadrilateral is always going to be 360. If we do 5 minus 2 times 180, that'd be 3 times 180, which is 540. You do 6,
Well, we just add 180.
exactly, and that's the pattern. You just add 180 each time. Every time you go up a side, you add 180. So what's a hexagon going to be? 720. How about a heptagon or septagon? 900. Now again, don't forget, that means the 7 interior angles of a heptagon always have to add up to be,
All the exterior.
900. and we're going to get to that here in 1 second. What's an octagon? 1080. Nonagon?
1260.
1296.
What is it, 1260?
1260.
Oh, yeah.
Decagon?
1440.
Be careful. What's a dodecagon?
Oh, 18.
1800? Had to go up twice, right?
Yeah.
Then an n-gon to find the
You put that
sum,
formula.
you put that formula in there. N minus 2 times 180. How about the sum of the exterior angles?
They're all 360.
They're all 360. Sum of the exterior angles of any polygon, always 360. All right, if the polygon's regular, these last two only work if you have a regular polygon. If you're trying to find each interior angle, go back to your sum over here, and you're just going to divide it by how many sides that certain shape has. So it's using the formula n minus 2 times 180, but then when you get done with that, finding the sum of all the interior angles, then you divide by the number of sides, and that's going to give you each interior angle if it's a regular polygon. Triangle, you should already know.
60.
Each interior angle, if it's regular, is 60 degrees. Quadrilateral, you probably already know also.
90.
Somebody tell me, see how smart you guys actually are, and see if you think before you yell out anything. What is a regular quadrilateral? A square. Don't maybe a bunch of them yell out.
Rectangle.
Rectangle. That'd be not correct.
Actually, a square is a type of rectangle.
Every,
Josh, now's not the time
Every
for
square is
shenanigans.
a rectangle, but not
No,
every
a
rectangle is
rec-
a square. Is it that way?
Say it one more time.
Every square is a rectangle, but not every rectangle is a square.
Right.
Yeah.
But they're all quadrilaterals.
oh no.
Pentagon. 540 Mr. A.
108.
Mr. A must be drinking too much coffee today.
Was that Mr. A?
Is that how he teaches? Just yelling? Never heard him go.
108 degrees. Now, be careful here, because can you just go up by a pattern?
No.
No, it doesn't work. How about a hexagon? 720 divided by 6 is what?
A heptagon doesn't have a regular number.
Yeah, it'll still be a number though.
It's 128.571.
Now you're one ahead of me.
I know, I said heptagon.
Oh,
We're still
but
hexagon.
still
Oh,
ahead.
hexagon is 144.
Now go on to your math.
That'll sound right.
720 divided by 6. Oh, it is 120.
So each
Whatever.
Each interior angle of a regular hexagon, 120. Now, notice so far, are these pretty common angles?
Yeah.
Yeah, the 108, the pentagon, not so much, but the other three real common angles, right? Those are ones that we use a lot. Now, what Peyton's saying about septagon or heptagon, what did it come out to be, Peyton?
Well, now you lost it. 128.57.
So let's do this. 900 divided by 7, that's 1. I'm going to divide it so I get a fraction number instead of that crazy number. 2, that's 14. Bring down next 0, 60. How many 7s are in 60? 6, 7, 8. Do I hear 9, 10, 11, 8? It's 56, right?
I don't do things in my head.
4 left over. So the way I'm gonna write this is 128 and 4/7 degrees. Do we use 7-sided figures a lot in the world? No. You know why?
Because they're weird.
Because of that right there, all right? They don't come out nice and even, so it makes them harder to deal with. How about an octagon?
135.
135, is that back to a normal angle?
E.
Yeah. How about a nonagon? 1260?
140.
140? Come out even? How about a decagon?
Throw away.
Was nonagon wrong?
What the dinkle dang.
No, it's right.
Decagon's 144. Didn't have to wait on Peyton to punch that in his calculator, because if you divide by 10, what do you do? You take off a 0. Dodecagon, 1800 divided by 12. What is it? 150. Then for each interior angle, what I do? I wrote that down one space too far. N minus 2 times 180 divided by N. How you gonna find each exterior angle if it's a regular polygon? Instead of taking this number and dividing by the number of sides, what do you take? 360 divided by the number of sides. Is that gonna be a lot easier to divide 360? Yeah, because you're just gonna do the same thing over and over again. When you see that, realize that, hey, dealing with exterior angles, even though maybe they don't ask you the exterior angle, dealing with exterior angles, then going back and find the interior angles, a lot of times will be a lot easier. So for a triangle, what's 360 divided by 3? What is it? 120?
Wait, what are we doing?
Each exterior angle. 360 divided by 4, what's that? 90. 360 divided by 5. 72. Anybody seeing another pattern here that would maybe make this easier than you dividing on your calculator every single time? What do we say about each interior angle and each exterior angle?
Yeah, 180.
They should add up to 180. So should we be able to find this one real quick? 60. This one here is a little harder. What's
41 and 3 seconds, right?
41 and 40, yeah, no, not 41. 51 and 3/7. How about the next one? 45. Next one. What's happening to the exterior angles as you get more sides? They're getting smaller. The interior angles got bigger, so the exterior angles get smaller. What's this next
Oh,
one?
I know the pattern.
36. Next one is,
60.
what is it?
Which one we at? Oh,
30. Then down here, it's just 360 divided by the number of sides, 360 divided by 8. So again, to find this, sum of the interior angles, n minus 2 times 180, because not everything's going to be on this chart. They're going to give you a 23 gon or a 48 gon or a 17 gon. So 17 minus 2, then times 180, that'll tell you the sum of the interior angles. Sum of the exterior angles always going to be 360. If it happens to be regular, take that number you got, divide by the number of sides, that'll tell you the each interior angle. You take 360, divide by the number of sides, it'll tell you each exterior angle. Everybody still writing that? All right, go ahead and jot these down. You don't have to skip a whole lot of space, but a little bit. Do these 4 problems, and then I think there's 2 other problems we're going to do together, a little tougher. All right, on these first ones, find the sum of the interior angles. And I'm going to use the formula, even though you could just look back there at that chart we just got done completing, and you could fill it in. How many sides does a pentagon? So 5 minus 2 times 180. Well, 5 minus 2 is what? So 3 times 180. How many interior angles does a pentagon have?
5.
So all 5 of the angles of any pentagon in this world should add up to be 540. We said something a little while ago about home plate. That's 90, that's 90, that's 90.
135.
Could we find those other 2?
130.
You already figured it out?
I did it earlier.
So 90, 90, and 90, that's 270. We subtract off that 270 from 540, and you're left with another 270. Well, these 2 angles are congruent on home plate. Divide that by 2. So that's 135 degrees, and that interior angle is 135 degrees. Sometimes, if it's not a regular pentagon, they may give you like 3 or 4 or 5 of the angles, and then you got to find the missing one by knowing what they all should add up to, and then subtracting off the ones that they tell you. Dodecagon, how many sides does a dodecagon have? 12 minus 2, what is 12 minus 2? 10 times 180, what do you do if you're multiplying by 10? Add a 0, so 12 angles of a dodecagon must always add up to be 1800 degrees. The 12 interior angles. What's the 5 exterior angles of a pentagon have to add up to be? 360. Guarantee I put problem on the test like that. Again, I'll have you working out all these problems, and I'll throw right in the middle one where it says What's the sum of the exterior angles? 360 every single time. How about for a dodecagon this? 360. Is that the one you're gonna miss, Nick?
No. You should just make a test over that entire question.
Just over that one question.
Oh, on earth, that.
70 more on it, like I did a point, or like 100 bullet points.
Then what would happen if I handed Austin's test back to him and he missed every one?
I'd be wondering what.
He's a false
going
prophet.
on.
Well, he would miss every one, but he might miss one or two.
It was just one question.
All right, write this down. These are a little tougher. These are the ones that are a little harder, so write these down. And I know you could probably figure out the first one without a whole lot of trouble, just because you know what it is, but I'm going to show you mathematically how to figure it out, so you know how to do it for any polygon, not just the easy ones. On this one, you're trying to figure out how many sides a certain regular polygon has if you know the interior angle. You could also be given the exterior angle and do the same idea. Is what we're getting ready to do. Now, in the past, I've always taught this the hard way, and this year I've given up on it. Because I wanted you to be able to do the long mathematical formulas, but I'm just going to show you the easy way. The harder way looks like this. We know each interior angle is 60. Then we have this formula. N minus 2 times 180 divided by N should equal that certain angle. And we could solve for N, which is the number of sides that the polygon is going to have. All right? And this isn't really all that difficult. All you got to do is multiply both sides by N to get rid of the fraction, then distribute out and solve it algebraically. But an easier way, if each interior angle, that's each interior angle, is 60,
Couldn't you just do one?
what's each exterior angle?
120,
120. How'd you get that?
because each two angles should equal 180.
All right, so the interior angle, exterior angle should add up to be 180, so you just take 180 minus 60, and you get 120. Well, the formula for an exterior angle, instead of being this big long formula, is just 360 divided by n, and we know that 360 divided by n should equal 120. And since we've been dealing with proportions so much, we could make that into a proportion by putting a 1 underneath that 120, cross multiply, and you end up with 120 times n, and most of you will probably figure out pretty quickly that, hey, I really don't have to do all that. I can just do it quicker than that instead of writing all this out. What's the next step? Divide by 120. So what's n end up being?
3.
So how many sides does this polygon have? 3. So what kind of polygon is it?
Triangle.
Triangle.
Which we should have seen because it's 6.
Brendan, what
Josh?
He's trying to teach.
But you probably should have picked up on that right off the bat, right? Hopefully that's one that if you look at it, hey, if each angle's 60, I know that's an equilateral triangle. It's the only one that works that way. So on this one, each interior angle is 170. What's each exterior angle? 10 degrees. So you got 360 over n should equal 10 degrees. It's like you're using the formula backwards is all you're doing.
And being 10 is kind of easy.
Right. So you got 10n equals 360, because when you divide by 10, what happens?
Just take off the 0.
Take off a 0 and you end up with 36. So how many sides does that polygon have? 36. What kind of polygon is it?
36 gone.
36 gone. Some of these, they'll give you something like this. And maybe they'll tell you these two are congruent, and maybe this one is 70 degrees, and this one's 70 degrees. How would you find, maybe I'd call that X, how would you find X there?
You'd add the two 70s together, and
Okay.
then subtract it from 360.
Because you know that this has how many sides?
4.
4, and if it's a quadrilateral, all 4 angles have to add up to be
360.
360. Now, what's that give us?
2. And then divide that by 2, and then you got
110.
Divided by 2, so X would have to be 110. Other ones, maybe a little harder one, sometimes if they're not a normal shape, which I know this still sort of looks normal, but a lot of them in the book won't be a normal shape. It might be some hexagon that looks all crazy like that or something, where everything's all different.
That's not a hexagon.
Or a pentagon, sorry. This one was a hexagon, I didn't get enough sides over there, did I? Maybe they tell you something like this is 52, this is 114, this is 110, this is X, this is 120, and maybe this one down here is 98. How could we find X?
You would add all that up and subtract it from 720.
Add all those up and subtract it from 720, because the hexagon, 6 interior angles always have to add up to be 720, and that would leave you with that last remaining angle. Don't make those harder than they are, that's why I went through them so quick. Alright, that's your assignment. You have about 22 minutes. Work on that assignment. Don't forget, before you leave,
I'm on board my last little piece.
laws test and the vocab up there. If you don't get the vocab before you leave today, make sure you get it into me next day or so. Please make sure your names are on anything that you put up there. Yes, week 5, if you go down to week 5, it gives you directions. Matter of fact, also, if you're gonna do it. I was gonna say, can you send something to print from your tablet? No. That's not everything, so if you wanted to come back here and use this computer, you could.
Wait, we can just print them all.
Yeah, it's on the, just go to Steven.
She had the computer on there.
She should. Where did I get the last time?
See, I was thinking you could print it off on my printer, but I don't think you could. I don't think this computer out here is directly hooked to my printer.
Slide.
I'm like, dang it.
Chapter
One
8
slide,
would
and the entire time I was like,
I was chapter 7 in the power go out.
So I just
Good
kind of
chapter
You
seven.
just- okay, no, 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 do it. Nope.
Well, I guess I.
Yeah, maybe he said that, and I was like, oh,
And then my
What's he
computer,
doing? That'd be kind of funny.
I saved it once I did my one slide, and then went to the internet to search for like a video to put on it, and then my entire computer froze. Everything froze.
Josh, you know, I
was like,
probably wouldn't
huh.
think that was so funny, except for the fact that how many times have you not done my homework at all? So-
Right.
So now it's like a
You
little
just made a
payback.
whole new computer.
Cause
It wasn't mine, it was
that
the
you didn't have to do that.
Oh, no.
Yeah, it just all froze up. I was like, are you sure?
You're like, oh, Lord.
Yeah, I slept, and I was like, oh. I'm glad I only did one slide.
What?
You only did one slide, like you were like 13.
Yeah, dude, I was just reading articles about the movie. I was like, I'm just gonna catch up on this.
Right. Your computer's bad.
How
many of you have run by tomorrow?
We had to have 30 today.
By today, so how many
You're just
did you run by
35,
next day?
like, and just